All right, today we're going to be talking about trig applications. The first thing we'll look at is road grade. So you have a road that has a 12% grade. What angle theta, and that's what that little symbol right there, that's usually used for an angle. Theta. What angle theta does the road make with the horizontal? So 12% grade is like it's like rise over run. It's kind of like a slope here. So we're going to write that as a decimal. That's going to be 0.12 when you move the decimal over twice for the 12%. And then that's like a ratio. 12% or 0.12 is the same thing as 12 over 100. So that means you're rising 12 and then the run is 100 right there. And then you're going to find the angle that's made with the horizontal. You're going to basically find what this thing called angle of elevation, which we get into a little bit more on the next page. So you have the slope of the road, the rise over the run is 12 over 100 again. So then we'll set up a trig ratio here for this. We'll label the opposite, adjacent, and hypotenuse. So across from your angle that you're trying to find, there's your opposite. The adjacent's down here at the bottom, and then the road itself is the hypotenuse, which we won't really even use here. Okay, so then the trig function that uses O and A, if we wrote SOHCAHTOA at the top of our page, this will help us determine which trig function to use. I'm not going to do this every time, but just as a reminder, so we're going to use the O and the A. That one is using the trig function that starts with the T, so that's the tangent function. So we'll say tangent of the angle, which we don't know, so angle x, and then equals 12 over 100. Okay. Now remember, to solve for an angle in the calculator, we're going to hit second and then tangent, and that's going to look like this here. It'll be tangent inverse, like that, which undoes the tangent basically, and then 12 over 100. Now before you type that in, just make sure that you check that your calculator is in degree mode. So I got that selected on the TI-84 calculator. It's the same way. You just hit the mode button and it's like the fourth option, I think, down. And then we'll hit second tangent, 12 divided by 100, and then apparently 6.8 degrees. What do they want us around to? Nearest tenth. So yep, 6.8 degrees would be great. Make sure you put your unit of degrees. That's how you're going to do road grade. So the big thing you need to know about road grade is whenever you see grade, this is like slope, the steepness, of a line. So, and slope is rise over run. So that'll be that type of problem right there. I think there's only one of these today. Oh, no, one more of these here. So road has a 8% grade. What angle theta does the road make with the horizontal? So kind of like before, we'll change 8% to 0.8, which is the same exact thing as 8 over 100. Okay, and then from there, we're going to go find your angle theta here. You could call it X if you want, if you don't want to use that symbol. Theta is one of the Greek symbols there. Label your opposite, your adjacent, and then your hypotenuse side. Okay, and then the opposite is 8, and then the adjacent is 100, so we'll use tangent again. So we'll say tangent. I'll put the theta symbol this time. I didn't do that on the last one. Tangent of theta equals 8 over 100. Which means we're going to type into the calculator tangent inverse of 8 over 100. And then you just do second tangent and then 8 over 100. You could, since 8 over 100 is the same thing as 0.8, or 0.08 actually, I should say, you could actually type that into the calculator like that instead of the fraction. So if you do 0.08, you could do that. You could also just go second tangent and then do the 8 over 100, but you should get the same decimal there. So they didn't give us rounding instructions. I guess I'll go to the nearest tenth again. That'll be 4.6 degrees for that answer. So make sure you get the 0.8 right there. I kind of messed that up there. Okay. So next here, we're going to see a couple of word problems here, and they're going to talk about angle of elevation versus angle of depression. They're going to give us an angle. They just got to figure out where it's located. So an angle of elevation typically will always be made with a horizontal, and then elevation's how many degrees up. So I'm going to draw an angle kind of going up like this right here, and I would even draw that angle or that little arrow right there, kind of like that. So it's how many degrees up that you're going right there. So that'll be an angle of elevation. An angle of depression starts with the horizontal again, but then it's how many degrees downward that you're going. So then draw an arrow kind of like that. That's an angle of depression, because that will change slightly how you set up some of the word problems that we're going to do here in just a second. So yeah, the word problems here, they're coming up here. You want to make sure you read everything, identify all the information. Usually you want to draw a picture and make sure you label everything in its correct spots. And then for the problems involving trig, make sure you write the correct trig ratio, label your opposite, adjacent, hypotenuse, and stuff like that. It says we're going to be using the tangent ratio. We're going to really be using them all right there. It's good to write the calculator ready form so we can check your work, see where you went wrong if you typed it in wrong. And then make sure you always round to the correct decimal place. Sometimes we'll bust you a little bit, point off or something like that for rounding errors. So let's go ahead and attack a few of these here, see what's going on. A building casts a 23-meter shadow along, or 23 long shadow with an angle of elevation of 54 degrees. Find the height of the building to the nearest meter. So apparently got some type of building. Draw something. So building kind of like that, and then there's a shadow along the ground. And then the angle of elevation to the top of that building apparently was 54 degrees. Remember, angle of elevation needs to start at the horizontal and how many degrees up that you're going. Okay. So there's that, and the shadow is 23 meters long. Let me write that in right there. Get this off of the bottom of the problem right there. And then they are asking for the height of the building, which means you need to find this dimension right here. Okay, so to start this, once you have the picture drawn correctly, then it's just kind of like yesterday's stuff. You're going to label your opposite, adjacent, and hypotenuse side. There's your O, there's your A, there's your hypotenuse. We're going to solve for x using the A. So solve for, I guess you have the O, the opposite, and then using the A. That's going to use the tangent function. So that'll be tangent. You'll put your angle 54 degrees. We're assuming you watched yesterday's video or saw the lesson here. You always go opposite over adjacent, so x over 23. And then we talked about the little shortcuts. Remember, if x is in the numerator, you would multiply both sides by 23 right there. Or you can treat it kind of like cross multiplication. It'd be 1 times x, which is x, and then equals 23 times tangent of 54. Which is actually the calculator ready form right here. So let's type that in, 23, whoops, make sure you don't have anything else there, 23 tangent 54, x is roughly 31.65, what did they say it around to? They did not say it around to anything, so I'll go 2 decimal places here. Let's go 66. And then let's get the unit here, that was in meters. And then that'll be good right there. So about 31 meters right there. I always like to make sure the answer makes sense here. So 54 degrees, that's one of your medium angles. Of course you have your 90-degree angle, so the hypotenuse should always be your longest side. But then 54 degrees, that's a little bit bigger. This other angle here, if you went and found that, would be, what would that be, 36 degrees. So 54 degrees is your medium length or medium, sized angle, and then therefore your side right there, your side length should be the medium side, should not be the smallest side. So you can kind of use a little bit of logic there to help yourself out and make sure you're typing it in right as a little check there. Okay, next one here, you got a kite is flying at an angle of 42 degrees with the ground, so that's an angle of elevation. And all 70 meters of the string have been let out. Ignoring any slack in the string, find the height of the kite to the nearest 10 meters, which is kind of weird here, so we'll talk about that here in just a second. But yeah, so you got a kite. Here, let's draw it like this here. So there's a kite flying somewhere up here in the air. Not really good at art here, but let's say that's a kite. And then it's making 42-degree angle with the ground. So you can go and put 42 degrees. That's an angle of elevation. And you're going to try and find that height right there of the kite right there. So we'll put X right there. That's what we're trying to find. And then this time here, it said there's 70 meters of the string. So that's going to be the hypotenuse since it is tied to the ground. So from there to there should be 70, which means we'll use a different trig function. Okay, so now if you go and label your O, your A, and then your H right there, the trig function that uses O in H is going to be the sine function. That'll be sine of 42 degrees, and then equals, and then the O over the H, or X over 70. Okay, if you have X in the numerator, you're going to multiply both sides by 70. That'd be 70 sine 42. And then we'll just type that in. And then apparently that comes out to about 46.84, I guess. And since they said around to the nearest 10 meters, that means our answer needs to be something like 30, 40, 50, or 60 meters right there. So you might not have seen a time where you round to the nearest 10 meters, but you're basically just kind of getting a rough estimate here, a very, very rough estimate, I should say. 46 feet is a little bit closer to 50, so we're going to round it up to a 50, what was it, meters, I think? Yep, 50 meters. So I would even say, you can even write out your answers like this here. You can say about 50 meters. And then that would be good there. And then, each of the problems are just going to be slight, variations of these here. So the more word problems we practice, probably the better we'll get here at these. So, next one, we're actually going to find the angle of elevation here. You got a 5-meter vertical pole, cast an 8-meter shadow. So you got some type of pole right there. Maybe it's a flagpole or something, I don't know. And then apparently it casts an 8-meter shadow. And you're going to find the angle of elevation, kind of like that right there. So angle of elevation is just like that. So we'll go and put, I guess we'll call it X here if you want, or you can call it theta. And you have the opposite adjacent hypotenuse sides here. So you will use the O and the A. We'll do tangent for that. So tangent inverse is what we're going to have to use. So tangent of X is 5 over 8. And then we'll do tangent inverse to undo that and solve for the angle. Make sure you hit second and then tangent for that. And then 5 divided by 8. And then about 32, let's go ahead and say that's about 32 degrees. Notice how I'm doing these little squiggly lines here. That's the symbol for approximate, because we're rounding, and usually we're rounding off part of our answer here. So approximately 32 degrees. All right, next one we have here is one with an angle of depression. You have a lighthouse, and it spots a boat out in the water. You could draw yourself a little lighthouse, whatever. I'm not a good artist. Angle of depression, spots a boat somewhere out here. And it's an angle of depression of about 20 degrees. So the way angle of depression works out is you go straight out from the horizontal, and then it's how many degrees downward. So we'll draw kind of something like that right there. And two ways you can apply angle of depression is you can say, okay, the 20 degrees is outside of here, and you can either use alternate interior angles and say, okay, well then that alternate interior angle is 20 degrees, Or you could use the fact that this should make a right angle right here, and you could go and use 90 minus the 20 degrees, and then say that that's 70 degrees up there, and then use that as your angle. So depending on which angle you use, if you use the 70 or the 20, that'll kind of change how the trig function works out there. So I will usually use the 20 degrees down here at the bottom. So I'll just use the alternate interior. Okay, and then let's go label everything else here. Apparently the tower is 70 feet tall, and then you're going to figure out how far the lighthouse is away from the boat here. And I'm assuming that's how far away. Yeah, we're assuming from the base of the tower right there to the boat. So then we'll set up a trig function there. We'll label our sides here. We have the opposite side. We're going to find the adjacent side. We're not going to use the hypotenuse here. So if we use the SOHCAHTOA, O and A uses a tangent function. This will be tangent of 20 degrees and then equals the, whoops, not 10, I guess that's 70. I covered it up there, 70 over x. And then you could cross multiply and then eventually divide, since x is in the denominator, right? This would be x times tangent of 20 equals 70, and then when you divide, it's 70 over tangent of 20. So then let's type that in and see what we get here. 70 divided by tangent of 20 degrees. That apparently comes out to approximately 192. Let's see, they didn't say any rounding, so I'll just say 192.32. And then let's see, units was feet. And that'll be it there. Okay, so we've looked at, quite a few of the different ones right here, so I think we're doing good here. We got another grade problem here. You have a road that has a grade of 5%. So 5%, if you move the decimal over twice, will be 0.05. Hopefully I don't mess that up again there. Which means that's a fraction of 5 over 100, which means with your triangle, you can say, okay, it's got a rise of 5, a run of 100, and then you're trying to find this angle here, x. And then this will be your O, this will be your A, this will be your hypotenuse. So we'll use tangent again. So pretty much all these grade problems, most of the times you'll use tangent on them. I haven't really seen a case where you don't. So tangent of x degrees, you're trying to find that angle of elevation, x degrees right there, is equal to 5 over 100. And then we'll type in tangent inverse of 5 over 100. And that gets us about 2.8 degrees. And they want to the nearest degree, so we'll say roughly 3 degrees. And that'll be it there. Okay, moving along here, I think we got just 3 more here. You got a truck driver drives up a 30-meter incline. The angle that the truck drives up is 23 degrees. To the nearest meter, how high vertically has the truck risen? Okay, so it's a 30-meter incline, so I'm assuming that means the 30 is going right here. And what was it, 23 degrees? And you're trying to find out how high vertically you're going. So we'll put x there for that vertical side. Okay, and then from here we'll label the opposite. The adjacent's down here at the bottom, and then the hypotenuse is at 30. And the sine function uses O and H. So we'll use that sine of 23 degrees and then equals x over 30. And then if x is in the numerator, we need to multiply both sides by 30. It's kind of using the little shortcut. Otherwise, you could just write it as sine of 23 over 1 and cross multiply. But once you do that, you'll get 30 sine of 23. That'll be roughly 11.7. And looking for rounding rules. They didn't say. Pay attention, though, to your rounding rules just in case. Okay, and nearest meters, so we're in meters. That'll be it there on that one. Okay, let's see here. This next one here is Martha is 66 inches tall and her daughter Heidi is 33 inches tall. Who casts a longer shadow? Martha when the sun is 80 degrees above the horizon, or Heidi when the sun is 40 degrees above the horizon? So basically we just got two problems here that we're doing. So I'll do for Martha over here, and then I'll do Heidi on this side here. So Martha is 66 inches tall. So, you could draw yourself a stick figure or something like that. Basically, all these are going to have a right triangle, so just make sure you draw yourself a right triangle and you'll be good. So apparently 66 inches tall, and the sun is 80 degrees above the horizon. So we're going to figure out what that shadow length is. And then for Heidi, she is 33 inches tall. So we'll put that there, but the sun is going to be only 40 degrees. And then we're going to see what that shadow is right there. So on both of these here, the setup will be pretty similar here. We'll label the opposite, the adjacent, the hypotenuse, and the trig function that uses O and A is tangent. So we'll say tangent of 80 degrees equals the 66 over x. After you cross multiply, you're going to get, x times tangent 80 equals 66, and then you'll have to divide both sides by tangent 80, so it'll be 66 divided by tangent of 80 degrees. And then that comes out to approximately 11.6, inches. And then now we'll go see what's going on here with Heidi for, kind of the same thing here. So it'll be the tangent function again, because O and A. This will be tangent of 40 degrees, and then equals 33, and then over y. I'm using a different variable just so we don't, mix them up there. And then cross multiply and divide. Eventually you're going to get 33 divided by tangent of 40. And I know that shortcut because y is in the denominator. We're going to have to divide. So now we'll do 33 divided by tangent of 40 degrees. Apparently that is going to be 39.3 inches. So who casts a longer shadow is going to be Heidi. And then by how much, I guess you could go and take your answers and then subtract them. 39.3 and then minus 11.6. And then, so I guess we'll say Heidi, they use an I, yep, they used the I. So I'd say Heidi by, 27.7 inches. And that'll be it. All right, one more. This one's kind of a special one here. I've seen stuff like this possibly on the SAT, so might want to look at this. They drew a picture, which is kind of nice for us here. So Will's flying a kite, 100 feet string here. It's making an angle of elevation from 25 degrees at 3 feet above the ground. So you have this right triangle, but it's lifted off the ground by 3 feet, which is going to play a role when we solve for the problem here, because they're asking how high is the kite in the sky. So right now we're going to go and figure out how high the kite is from that point he's looking at, and then we'll incorporate the 3 feet in just a second. So let's set this up like a normal math problem here. I'll label O, A, and then H right there. A trig function that uses O and H is sine. We'll say sine of 25 degrees, and then equals x over 100. Okay, and then x is in the numerator. That means we need to multiply. This will be 100 times sine of 25. And then that'll get us roughly 42.26, and then I guess that was in feet. And let me go ahead and write that over here. This x was 42.26. All right, so that is the height above from where he is looking straight out, or I guess where he's holding the kite. And since he's holding it 3 feet above the ground, what we're going to have to do is add on that 3 extra feet that he is above. So When you do the 42.26 plus 3, you'll get the 45.26 feet right there. And that'll be the total height right there. So watch out on that one. You just basically go and add on your extra distance at the end, and that's it. I believe that is it here for the unit.